The cosine rule can be used to work out missing sides or angles in triangles. For example, let's take this triangle labeled ABC. The length of the sides of this triangle are A, B and C. The length of the side AB is C and BC is A and AC is B. So now here we can divide this triangle into two right angle triangles. So let's label this point X. As you can see here, there are two right angle triangles. Now let's say the length of AX is X. So the length of XB is C minus X as the length of AB is C. This is because AB equals AX plus XB, so XB equals AB minus AX equals C minus X. And the length of CX is H. Now the right angle triangle CAX has a hypotenuse B, so now using the Pythagoras theorem, hypotenuse squared equals opposite squared plus adjacent squared here. In the triangle CAX, B squared equals H squared plus X squared. In my previous PO Maths video, I covered about the Pythagoras theorem and the names of the sides in a right angle triangle, so first check it out or else it might be confusing. Now moving on to the right angle triangle CBX. Here the hypotenuse is A. So using the Pythagoras theorem in the triangle CBX, A squared equals H squared plus C minus X squared. Now we have two equations. So this is our first equation and this is our second equation. Now you can solve these as simultaneous equations. Subtract the second equation from the first equation in order to remove H squared. So B squared minus A squared equals X squared minus C minus X squared. Expand the brackets, then B squared minus A squared equals X squared minus C squared plus 2CX minus X squared. B squared minus A squared equals 2CX minus C squared. Label this as the third equation. Remember, you can use the standard trigonometric ratios for right angle triangles to prove the cosine rule. Now before moving forward, let's take a quick look through the standard trigonometric ratios for right angle triangles. So here is a right angle triangle with an angle labeled theta. So now this is the hypotenuse. If we look from this angle, this is the opposite and this is the adjacent. Now the standard trigonometric ratios for right angle triangle are sin theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse and tan theta equals opposite over adjacent. So now if we look back at the triangle ABC, in the right angle triangle CAX, we can use the cosine ratio to find the angle A. So cos A equals X over B as cos theta equals adjacent over hypotenuse. Now rearranging this gives us X equals B cos A. Label this as the fourth equation. Now we can combine the third and the fourth equations. So substituting B cos A instead of X gives us B squared minus A squared equals 2C times B cos A minus C squared. So B squared minus A squared equals 2BC cos A minus C squared. A squared equals B squared plus C squared minus 2BC cos A. Now, in a triangle, if you are given two sides and the angle between them, you can use this version of the cosine rule to find the missing side. So, if we take this triangle ABC and we are given the length of the sides AC and AB as B and C with the angle A and asked to find the missing side A, we can use the formula A squared equals B squared plus C squared minus 2BC cos A. Now remember, you can exchange the letters depending on which side you want to find as long as each side has the same letter as the opposite angle. So let's take a look at a few examples. Calculate the length of the missing side. Now here we know the lengths of the two sides AC and BC and the angle between them. So using this formula, we can find the length of the missing side AB. So AB squared equals 5.6 squared plus 6.5 squared minus 2 times 5.6 times 6.5 cos 108 degrees. Then AB squared equals 73.61 minus 72.8 cos 108 degrees. So AB equals 9.80 centimeters. Here I gave the answer to three significant figures. Now in this triangle we know the lengths of the two sides AB and AC and the angle in between them. Now using the cosine rule, we can find the length of BC. So using the formula, BC squared equals 6 squared plus 5 squared minus 2 times 6 times 5 cos 45 degrees. BC squared equals 61 minus 60 cos 45 degrees. BC equals 4.31 centimeters. Now in a triangle, if you are given all three sides and asked to find an angle, the cosine rule can be rearranged. So 2BC cos A equals B squared plus C squared minus A squared. Dividing both sides by 2BC gives us cos A equals B squared plus C squared minus A squared over 2BC. This version of the cosine rule is used to find an angle if you know all three sides. So if we take this triangle ABC and we are given the lengths of all three sides as ABC and is asked to find the angle A, we can use the formula cos A equals B squared plus C squared minus A squared over 2BC. For example, calculate the size of the angle marked X. Now here we know the lengths of all three sides, so we can use this version of the cosine rule to find the missing angle X. So cos X equals 6 squared plus 9 squared minus 14 squared over 2 times 6 times 9. Cos X equals minus 79 over 108. Now to solve this equation, take the inverse of the cosine function. So X equals cos inverse minus 79 over 108, then X equals 137 degrees. Now if we take this example, here we also know the lengths of all three sides. Now using this formula, we can calculate the size of the angle X. So using the formula cos A equals B squared plus C squared minus A squared over 2BC, cos X equals 4 squared plus 8 squared minus 10 squared over 2 times 4 times 8. Cos X equals 80 minus 100 over 64. Cos X equals minus 0.3125. So taking the inverse cosine, X equals cos inverse minus 0.3125. X equals 108 degrees. Now let's take a look at another example. Find the value of X. Here the lengths of all three sides with an angle are given, so we can use the cosine rule to find the value of X. So using the formula A squared equals B squared plus C squared minus 2BC cos A, then X plus 3 squared equals X minus 3 squared plus 8 squared minus 2 times X minus 3 times 8 cos 60 degrees. Cos 60 degrees equals 1 over 2. So expand the brackets, then X squared plus 6 squared plus 9 equals X squared minus 6X plus 9 plus 64 minus 8X plus 24. Collect all the like terms, then 20X equals 88, X equals 4.4 centimeters.